Oh, I didn't get it recorded? No, I didn't get that recorded. And so you'll have the ability to earn free drinks and chips or fries at Cousin Subs.
Wow.
By answering questions correctly.
Oh boy.
Just giving them away yesterday.
Well, you had to do the raffle thing. You had to sign up for the raffle thing. This was the if you were a loser, they give them away. This is what you got if you didn't win.
Where was it at?
What this? It's right across this. You were supposed to say right across from the Apple Watch demo.
Well, that's where it was. They have fries at Cousins?
I didn't know that either.
They got cheese curds at Cousins.
Oh, yeah, but that maybe makes more sense. But fries.
Fries and a sauce.
Yeah. All right. So, homework assignment was to create a simple PCB data structure for representing a process in our operating system. Okay, and you were supposed to write this in C.
Well, didn't we already have it done?
Yeah, you already had it done in Z. All right, so let's go ahead and open up Eclipse here. And let's close all this stuff. And I'm going to create a new project here called Operating System. We'll call it OSSIM. We'll create a new class. I'll go ahead and just make our driver just so we have it. And then I'll create a new class, and we're going to call this guy PCB. All right, so here's our PCB class. So let's talk about this. So we go through, and so this is the last slide I put up at the end of class, right? So we talked about this is what the basic stuff we need to remember about a process. So we need to remember its process ID. So this is a unique identifier. So we're going to have a field, probably named PID. And what type should that be? Int is reasonable enough for us. That allows us to have how many unique processes on our system at a time? 2 billion, right?
Couldn't it actually be like 4 billion because you could start with a negative?
You could start with a negative, I guess. So I suppose you could start with a negative 2 billion and actually get 4 billion. Okay. Now, if you had gone with a long, it would be about to what, 4 quintillion? It's more processes, but we'll just go with an int. So int PID. All right. So that's going to be our process ID. Then we have a state. Well, what are our options for states?
5 options.
Ready, waiting, running, terminated, new. Those guys? All right, so, they're representing. Okay, you could do it as a string. What I might do is probably the computer science appropriate way of doing this would be this. I'm going to create a, and actually we can house this inside of the PCB. You probably haven't seen this before. So I'm going to create a class called PCB states. Good enough. And the class PCB states is going to have several static fields in it. So we're going to have static let's say string new is equal to, well, let's do state 0. actually, I don't want it to be a string, I want it to be an int. Sorry.
And we're just going to do 1 through 5 or 1 through 4.
Yep, so then we have ready is 1. Then we have running is 2. We have waiting is 3. And we have terminated as 4. All right, so that's going to be our PCB states, ideally. And you'll see how we use this here in a second. So we're going to have a private PCB state. Let's call this PCB state, not states. Private PCB state. State. All right. Then we have an unsigned int time slice. So that's going to be probably a variable that's managed by our process. Well, actually, it'll probably be managed by the CPU scheduler, which we kind of talked last time, that you might be separated into 2 things. That might be 1 thing. So we have int time slice. Okay. So now we have the process's parent. What is the process's parent? The parent of a process, if we fork a child, who's the parent of our process? If I'm the child, so I'm a brand new PCB, right? Who's my parent? What kind of animal is my parent? PCB. So private PCB parent. Let's see. Then we have the list of open files.
You forgot children.
Where do we go?
To the right of it.
Oh, list of children. Okay. So list of children is going to be probably, how many children does a PCB have? 0 to X. Okay. How do we store things that are, how do we store a list of an arbitrary number of things? Linked list. So we're going to have a private linked list of PCBs called children. And we can go ahead and set this guy equal to a new linked list of PCB. And then we need to import java.util to give us linked list.
Wait, we can do that.
Do what?
I don't know, this is new stuff.
Yeah.
PCB inside the brackets.
Yeah, now it's not a, I don't think it should be new stuff.
We didn't really go over it.
You've probably seen it before. So when you create a linked list in Java, if you use the built-in linked list, it gives you a generic linked list capable of holding objects. So when you pull them out, if they are PCBs, you have to typecast them back to PCBs. If I use this syntax, this is called generics. If I use this syntax, it says treat the linked list as actually being filled with PCBs. So when I add stuff to it, requires a PCB. When I take stuff out of it or retrieve a value, it comes out as a PCB, so I don't have to cast it. I don't have to turn it from a generic object into a PCB because I know it's a PCB. Make sense? But for this assignment, I would have expected you to implement your own linked list, which is only going to work for PCBs. How many of you did that?
Oh,
We
we
just didn't change no to PCBs.
we used our old linked list from last semester, but we didn't change I think it was supposed to hold payloads, which were ints. We didn't change that to PCB. We thought about it, but didn't actually do it.
So you belittled the children. Said, look, you're supposed to be a PCB, but you're actually just an int.
For the moment. And when we need to change it, we'll change it.
An array list is fine. An array list is essentially an elastic array, but why did you use that instead of a linked list?
Because that was the documentation I came up with on first.
Was the documentation, did it start in your head?
Like in my head, like I had the idea of like I wanted to use a linked list, and then I went back to the stuff that we had before, and I was like, well, I just use this stuff that's built in.
I don't think I ever introduced array lists.
No, I mean the linked list from class. I still have the code for that.
You just said you used array lists.
I did, yeah. But I heard, like I thought like there was no linked list thing like that.
Oh, you thought there wasn't a built-in linked list in Java.
And I thought array list was the closest thing I could get.
Okay. I got it. I always introduce the actual linked list after I make you guys write it yourself in 300.
You showed it.
Yeah, so you're just being stupid.
I don't remember seeing this before.
Because you don't study.
You just told Austin he doesn't study. If anyone studies, it's Austin.
What's up? If anybody studies it, I agree with that.
Or Joel.
Austin and Joel. Zach does. See who else studies. No, he doesn't study.
I don't need to study. Just get everything.
I have to study. I have to study.
Ian doesn't study. Got football in the mind, right? How's the team this year?
You know, like study off the document, just get everything.
They're getting better.
You're still playing, right?
No.
You don't play? Why? Well, you only played 4 years? Oh my gosh. So what's on your mind this year? I don't know what I'm going to do with Ian. Drinking and girls, is that was yeah. All right, so we have our linked list of children. So it's going to be a linked list of PCBs. What else do we got?
Then it's the files.
All right, so a list of open files associated with this guy. So as far as we're concerned right now, that's going to be a linked list of, let's just call them files. And this should be in java.io. So a linked list of something, right? We don't know if we're going to have 0 or X open files. Okay, and then ultimately the address space of this program is going to be the kind of the actual lines of code, right? All right, so maybe we call this private linked list. For right now, let's just say our lines of code are strings. So let's call this guy instructions. And then finally, program counter, which should start off at 0. Is that an initial take on a PCB? Okay. Constructor. So let's see, it's just Java. Okay, so we're going to say public PCB. When we build a PCB, well, first of all, let's start with this. Who is building a PCB? A PCB doesn't just come into existence, right? What I'm really asking is, who knows about the PID? Whoever creates this PCB is the one who's putting it in ultimately into the job queue, right? And who is that? The process scheduler. All right, so we're going to have some program somewhere, the scheduler, who's going to say, oh, they've double-clicked, or they were notified or whatever, that they've double-clicked on Microsoft Word, and all of a sudden they say, new PCB, your process ID is this value. So the process ID is going to have to be brought in, because that's the only person who's going to have kind of the master list of all the existing processes and make sure that they give this guy unique PID compared to the rest. Make sense? All right, so this guy's going to have to take in an int PID as a parameter when he's being built. Make sense? So we'll say, this is Java, this dot PID is equal to PID. What's the initial state for a PID? When a PID, or I'm sorry, when a PCB is first born, what's his initial state? New. So we'll say this dot PCU, what do I call it, state? This dot state is equal to PCB state dot new. Oh, this guy is going to be an int. I would have to make it an enumerated type if I wanted to call it a PCB state. So he is going to be an int, and the int he's going to be is PCB state.new. PCB state's the name of our class. Here's a static field in that class, so we call static fields using the name of the class in which they were defined. So PCB state.new will ultimately boil down to a 0 right now, but if at some later point in time we upgrade our operating system, we just decide to rearrange the orders of these integers, as long as we always use new, ready, running, waiting, terminated and associated with some numbers, and we use them around our program, then even if we change the numbers here, it'll always remain true throughout our application. Make sense? This is why this makes more sense. This is probably also the first time you've at least seen me throw an extra class inside of a class. Well, inside the same file as a class. So we certainly could have put this on our own separate file, but it's kind of a little tiny helper class for PCBs specifically. Okay, so maybe it makes sense to kind of keep it with our PCBs. That's why I threw it in here. All right, so the state will start off as that. Now, also, this guy is going to have an initial time slice. Now, when he's first born, he hasn't been given any time slice, correct? Look, I'm new. I haven't even gotten in line for the CPU. Time slices don't make sense if I'm not in line for the CPU. Okay, really, they don't make sense until I'm ready to get the CPU. All right, so the CPU scheduler is probably going to notify me what my time slice will be later on. Make sense? Okay, so this is a private field, so at some point he needs to be able to set that time slice. So what I'm going to do here is I'm going to right click. We'll go to what is it, source, generate setters and getters. And we'll go ahead and we will go to time slice, and we'll generate both a getter and a setter, so that a CPU scheduler can set the time slice for a PCB, okay? And he can also get the time slice for the PCB to decide when he needs to kick them off the CPU. Make sense? So we'll go ahead and give those.
Generate again.
Under, if you right click, and then it's under source, I think. Yeah, source, generate getters and setters. Or you could have just written it yourself. Short little couple functions. So you should write them yourself until you feel like this would be a waste of your time to write it yourself. Okay, so until you feel that you can just write these off the top of your head and never make a mistake when writing them, you should write them yourself. All right, so get time slice. Let's start off with time slice is equal to 0. It has no CPU time initially, so we'll just give it an initial value. All right. Parent. Who's this guy's parent? He's his own parent? What kind of sick world do you live in? So we want to think about this from the operating system perspective. So if this guy's the original, all right, so the process scheduler, somebody's double-clicked on Microsoft Word, the process scheduler then says, okay, I need to bring a PCB into existence. Who's this PCB's parent going to be initially? Null. He has no parent. Right? I'm the top of the stack. If we think about this as a linked list of PCBs, which is kind of a lineage, our parent, which should be a PCB, isn't a PCB. Right? So maybe the process scheduler can say, okay, well, maybe the process scheduler decides, you know, I'm actually a PCB. Would they be? Is the process scheduler some sort of mythical entity inside of our computers, or is it a program just like any other? Mythical entity, it makes sense. So he's probably a program just like any other, right? So therefore, would the process scheduler be the original PCB in the system? Yeah, probably. So now the question is when we're creating a PCB, if a PCB doesn't have a direct parent other than the process scheduler, does he need to know that the process scheduler is his parent? We want to kind of think about under what circumstances does a PCB need to know about his parent? When's that an important thing to know? Whatever you're forking. Okay. Why is that important then?
So you know when it's forked, which one would continue to do the same thing and the other one not.
Well, that's the result of a. Okay. Well, actually, let's go down that. Let's go down that route. The fork system call returns a int, returns a process ID, and it returns a 0 for the original and a real process ID for the other one. Now that 0 for the original doesn't mean that the original's process ID is 0. That's just his way of telling that he's the original, not the clone. So if you put yourself in the shoes of a PCB, and I say, okay, well, I'm going to spawn a child. Do I need to know about my parent to do that?
No, but
Short answer is maybe, right? Okay, but our initial guess here, let's just kind of play it out like a soap opera, right? And that's what we're doing. We're trying to pretend like these are all actors in the play that is called our operating system. Right? Go ahead.
wouldn't the child need to know about the parent?
Child certainly needs to know who their parent is, but if you are the top level guy, you're the original Microsoft Word PCB, and you spawn off a child, the child should know that the parent is the Word PCB. But does the top level Word PCB need to know who his parent is? Or does the fact that he doesn't have a parent, setting his parent to null, is that good enough?
Why wouldn't it be?
Reasonable. I think it's a reasonable position. So why don't we set it? Why don't we operate under that assumption for now until we come up with a reason that the top level guy needs to know about his parent, right? Why should the process scheduler, we might say, does the process scheduler actually need to be a PCB? The answer might be yes, the answer might be no. All right, so, but he might need to be. Something we forgot up here is the registers, but whatever for right now. Okay, so that means that is our constructor complete?
Sure.
What if you are a child PCB? What if Word spawned you? I'm the new guy. A PCB is a PCB. Some PCBs have an actual parent. Other PCBs don't have a parent. But every PCB needs to know about the status of their parent, don't they? So do we need to have the constructor take in the parent?
Sounds like a plan.
PCB parent, this dot.
Then if it is the original, how do you just pass it null?
Yeah, well, I mean, either pass in null, or maybe we decide when we're writing our process scheduler that the process scheduler says, all right, I'm creating this new top level PCB. I'm either going to give them a null value first parent, or if I'm a PCB, if I'm the process scheduler and I'm a PCB, maybe I'll just say, your parent is me. I'll just let him know about that. So then so the problem with that, the potential problem with that is, in order for a process to know whether or not he is the top level or not, he either needs to check for a null value or he needs to know the PID of the process scheduler. That needs to be a known entity somewhere in the system. So that he can ask, do I have a parent? Well, in that case, the answer would always be yes. So really what you're asking is my parent the process scheduler, or is my parent some other PCB? Okay? So this is information that we may or may not need to work with later on. As far as we're concerned right now, maybe our process scheduler, when he births a top level PCB, he passes in null for the parent, and that's how a PCB knows if he has a parent. Okay? If he's the top level, his parent would be null. If his parent's not null, then he actually has kids. He has child processes. Make sense? Well, no, I'm sorry. Then he is a child of some other PCB. All right. So that's parent. So now we've amended our constructor to take in a little bit more information. Our linked list of children is already initialized. Our linked list of open files is already initialized. Our linked list of instructions is initialized to be empty, but can a PCB exist without there being a list of instructions? Yeah, I mean, that's the point of a PCB, right? Like I need to have something to feed Pac-Man, right? To feed the CPU. So this guy needs to have a list of instructions, so it wouldn't make sense for him not to have a list of instructions. So we're going to have to pass those list of instructions in, or set them in some way, right? So we're going to go ahead and pass them in. So we'll say we're going to take in a linked list. Like right now it'll be strings called instructions. All right, and then we can just go ahead and say this dot instructions is equal to instructions. We don't need to copy them over because we have a pointer to them. So more than likely what will happen is that process scheduler will grab the instructions associated with the executable that's on the hard drive as he's generating a PCB from a program that lives on your hard drive. He'll grab the list of instructions, he'll pass it into the PCB while it's constructing the PCB. He'll say, you are PCB 5. I am your father. Or maybe he says null is your father, however we decide to handle that. And here are your 300 magic tricks that you should use to feed the CPU so you keep it happy. Make sense? Those are the things that will come into a PCB when it's being created. All right. Then, private linked list. We have something called a register. All right, and this is going to be register values, and this is going to be a new linked list of registers. Okay, now right now we don't really know what a register is, but realistically it's probably going to be a name value pair. Correct? You know, when we think about the CPU registers, they're going to be, they're physical pieces of hardware. Correct? Registers are physical pieces of hardware. But from a software perspective, we have a register maybe named AX. That's one of the registers. Okay, it's one of the original registers. So it's an 8-bit register. So we have an old register, AX, and he has a value associated with it, right? It's a name-value pair. So he's a physical entity. The PCB needs to keep track of those physical entities, the current values of them. So does anybody else need to know about registers from a software perspective in our world other than PCBs right now? As far as we're concerned right now, a PCB needs to know about that data structure that is a representation of a register, right? All right, so why don't we go ahead and put it up top here. Class register. And let's just start off with 4 registers. We're going to keep this as a real simple CPU. All right. So this is going to be static.
Would the
If it's in, go ahead.
would it be name value pairs, or would it just be a pointer to where, like, I guess, what are we trying to get at in the register? Isn't it just a place?
No, we want to name register is a hardware variable.
Okay.
So we're probably going to keep track of a private string name and a private. Realistically, we always store values in the registers, numbers in the registers, but those numbers are stored as binary data, 0s and 1s. So for us, why don't we just store it as a string? We'll just treat it as it's the binary value. So we'll say string binary value. That's an easy way for us to hold 0s and 1s. Okay. We're certainly, or if we're writing a simulator here, the goal isn't necessarily top end speed, right? All right, so a register is going to have the name of the register and its current binary value. So some registers will have 8-bit value, some will have 16-bit value, some will have 32-bit value, so on and so forth. Okay? So we're not really keeping track of that, so we could potentially add to this data structure number of bits or something like that, but keep it simple for right now. We can always expand this as we need to. All right, so a register is just a name value pair. So here's our register values. It's going to be a linked list of registers. So now, when a PCB is first born, who's in charge of passing it those register values? Or let's ask it a different way. When a PCB is first born, does he need to have register values? Correct. We only need to remember register values after we visited the CPU, if we intend on visiting again, right? So we can unpack our bags. So our register values will become initially set when we first context switch off of the register. Make sense? That's when it'll get filled. After that, we'll have to update it. Okay, so we are going to need ways of accessing this. We can open up those mechanisms later on, but somebody, probably the CPU scheduler, okay, or maybe our data structure representation of the CPU, as he's kicking somebody off, we'll have to decide whose job that is. So once a PCB is run out of its time slice and he's getting kicked off the CPU, it's going to be somebody's job to pick him up and drop him off the CPU. But before that happens, he has to scramble and fill his fill up the register link list. But understand, as it stands right now, a PCB isn't an entity. It's not a living thing. It's a structure for holding information. Okay, so now we want to start thinking about our operating system as kind of like a little world. I like to think of it like the Ewok village. See that Star Wars theme? Get that? It's Christian worldview. How is Ewoks not a Christian worldview?
It's based on
They
PCB
worship the
theology.
book. It's a god.
Is it really?
Yeah, the whole Star Wars series is.
Yeah. So there, isn't that shouldn't that be a goal of us Christians to convert the Ewoks?
That's why Luke went there in the first.
Yeah. Seriously,
The Jedi.
it was a mission trip. Luke Skywalker was on a mission trip.
Oh,
Somebody handed dude a
He
lightsaber.
started worshiping C3PO. That's
Yeah.
kind of. I think that.
Gold idol.
Yeah.
Worshiping idols.
Directly connected, right there.
You didn't make that point.
You did, and I drove you to that. So that is me.
That's double point.
Yeah, that's evidence of Christian worldview being incorporated into this class through Star Wars, which is triple points. All done through Ewoks, which is quadruple points.
Getting into heaven based on a point system.
Huh?
Getting into heaven based on a point
That's right.
system.
Mormons for the win.
I think next semester I'm gonna start counting all of your Christian worldview points.
Yeah, so then in the end, when you're filling out the evaluation, like, I just don't have enough bubbles. Complained to Dr. Cario. It's like, look, I tried to fill this out, but I mean, we're in the hundreds.
Stacking triple points. Quadruple.
I mean, we're talking Ewoks. Ay, ay, ay. Okay, so that was a good one. I like that. So oh yeah, that's right. Our operating system is kind of like a village, right? So we got some things in our operating system that are kind of living entities, crawling around, doing things, right? And then we have other things that are kind of like baskets. They just hold on to information. All right. So a PCB is like a basket. It holds data, but he's not an entity that's marching around on its own. Okay? He's got to be carried around by somebody else. So process scheduler throws him into the job queue. The process scheduler throws him into the ready queue. The CPU scheduler grabs him from the ready queue and throws him at the CPU. CPU is working with this guy directly. He's reaching into the basket, grabbing stuff, whatever. When he's done, the CPU either the CPU is throwing him back, or the CPU scheduler is grabbing him back and passing him off to wherever he needs to go. Right? Okay, so start thinking about the operating system as this world where we have some things that are skittering about, and we have other things that are just baskets filled with stuff. PCBs are the baskets. Right? Now, having said that, could we make a PCB its own little entity?
How would we do that?
Well, I mean, you thread them. Okay, that's a euphemism. Christian worldview. All right, so in any case, why would it be a bad idea for our PCBs to be, quote, living entities in our operating system? Every living entity, by definition, is a PCB, right? It's if you are doing something on the CPU, at some point in time, you're interacting with the CPU. Doing something in the operating system, at some point in time, you're interacting with the CPU. So if every PCB was also a living entity, they're kind of like two PCBs.
Yeah.
So one side of it is what keeps me alive. The other side of it is what is my job. Does that make sense? And since our CPU is the resource that's using it, if we kind of think about that dynamic, so in a single core thing, so right now, oh yeah, Ian would make a great CPU. All right, so Ian, you're going to be our CPU. So right now, if Ian's the CPU and I'm a PCB and I'm a living entity, I'm going to walk up to Ian. We're going to kind of fight a little bit, until we decide, is he taking the instructions or am I giving him the instructions? And it's kind of a bullying type situation. So that doesn't seem efficient, does it? Doesn't seem efficient. Whereas if I was just a basket, and somebody put this basket in front of Ian, the CPU, and said, "It's like here, it's his turn. Eat, just don't kill the children," something like that. So now Ian, being the CPU, he can start feeding out of the basket until the CPU scheduler comes in, probably with whips if we're going back to some old age type stuff. The Ewok village. So now somebody's going to come in and grab that basket from you, and you go, now Ian's pissed, right? Like, look, I am supposed to be busy eating all the time. Okay, how many of the minutes? All of the minutes. Okay. So now, so we got to, okay, let me just pack this up real quick. Say, here. All right, so PCBs being living entities probably doesn't make tons of sense. First of all, it would be really sad because, you know, as you know, Ian is feeding off the PCB, I'd be the PCB who's sitting there squirming. Yeah, no. Is that the sounds Ewoks make?
No.
Does Pac-Man eat Ewoks?
Definitely. Yeah, definitely.
See if there's a
Ewoks are
YouTube
actually
video.
ghosts.
So Pac-Man eats the ghost of Ewoks.
Yes.
So therefore, there's an afterlife. Do the ghosts live in heaven?
Oh, great.
Christian world.
Boom, boom. Abba. All right. So, in any case, our PCBs are probably, at least in our initial assertion of what they should be, probably are not living entities. They're baskets, right? CPU definitely a living entity. He's got a job to do, right? So wait a minute. How can the CPU be a living entity if he isn't a PCB? If the CPU eats a PCB or feeds from PCBs, how can he be a PCB himself? Doesn't that create a chicken or the egg type problem? Is that Pac-Man eating Ewoks? If it is, that would be epic. Somebody made this video. What is it?
It's a cat.
Cat doing what?
Eating.
Just eating in general? So you're just watching a video of a cat eating.
It sounds like an Ewok.
All right. So doesn't that create kind of a chicken or the egg problem with our CPUs?
If you say the CPUs, it's not. It's a special kind of PCB.
Is it?
Well, no, you just say it's a PCB and its process is eating PCBs.
Okay. Does the CPU need to be a PCB?
I just said that and you said yes.
You're the one supposed to be answering the question.
But then you told me my answer to the question was no, it doesn't.
I would never tell you your answer to any question is right.
I think I got a little card here that says otherwise. It says I got a question.
You have to buy a 7.5-inch sub first. 7.5-inch sub before you get free
Really
fries.
just marketing, because now I think I might go to Cousins
Really?
today or tomorrow. You know?
Yeah, actually, they were our enemies yesterday because they were taking away our customers.
Hey, customers who are selling things?
We weren't. We should have. We should have had a raffle for Apple Watch. We got a whole bunch of people sign up.
I only have one of those at the gathering.
Do we not?
I don't know.
I think you have an iPad Air again, but I
Yeah.
don't think I have a watch.
Yeah.
Ooh, was this in the list for the email or something?
Yeah.
Yeah.
I'm not in charge. Above my pay grade.
Should make suggestions.
I'm buying
Are
free
you?
runs next semester.
You buying what?
I'm buying free runs next
We
semester.
could actually a suggestion thing.
All right. So
It's actually not a bad idea.
if you think about a CPU in a computer, what does it look like?
A city.
C3PO.
Is it a piece of software or a piece of hardware?
Hardware.
It's a piece of hardware. It's a thing. It's a pre-decided thing, right? A CPU is what it is. So it's something that's plugging into our computer. It's nothing that software can control. We can't make a decision at the software level about what the CPU is. The CPU just is. Right? Might be a Christian worldview. Maybe. Yes.
CPU is the great I am.
Yeah, exactly. See? Nailed it. All right, so in any case, the CPU would not be a PCB Because it is a CPU. It's a physical piece of hardware. It's a running wood chipper that we just throw things at, and it does its thing, whatever its thing is. Okay? Now, that isn't to say we might not have a data structure that abstracts at the software level our CPU, that allows us to kind of stage things for the CPU's feeding, right? So we might have a software level, but it isn't a PCB. Right? It's not being scheduled. It's there all the time. Right? The only reason we even need to have this PCB is because we're doing scheduling crap. CPU's always there. He's always involved. He's always trying to grab instructions out of our PCB baskets. All right? So, anything else we need to do here for our PCB as our initial step? Seems legit enough. All right, so
Where do the register values come from?
that would be during the context switch. Remember we talked about that?
Yeah.
Like 10 minutes ago we talked about that. Your mind's on Ewoks and cats
Do
eating.
we have to do anything with the program counter? Or no, since it's already,
Well, the program counter gets adjusted when what?
when you.
Well, when we're feeding, right? So as Pac-Man is eating instructions from the PCB, the program counter will be adjusting, right?
So it'll constantly update it, not when it leaves, it does it as it's doing
Yeah, as it's doing it, so it knows which thing to grab next.
I suppose it
Okay, so Ian's a very discerning devourer. He looks in there and finds out which instruction he's supposed to eat next. So now, Ian, if I give a quiz on this and you miss it, that's saying you don't know how to eat. Okay, I'm just going to say you look like you know how to eat. Yeah, just a little. He's got some meat on him, is what I'm saying. Gotta offend everybody. All right. So that makes sense? So, what is a process scheduler then in this context?
The process scheduler was the original PCB.
Okay, potentially. But at the very least, he's the guy who generates PCBs. And he's the guy who manages the job queue as PCBs are being born. Right? So, given this as a starting point, and I'll paste this in, for Monday, create a data structure for a process scheduler. What he should do is he should have the ability to create PCBs, hand them probably a null for right now, the parent. You can give them a random linked list of strings for instructions if you'd like. It's reasonable enough, just fake instructions since we don't have a CPU that actually does things as a response. And ultimately fills up a linked list of PCBs, probably called the job queue. Make sense? So, just like today's assignment, create a simple process scheduler whose job it is to create some PCBs. He needs to keep track of what the process ID should be, some counter. First guy's going to have process ID 0, then 1, then 2, then 3, then 4, blah, blah, blah. Create the PCB, pass it in some random stuff, add it to my job queue. Make sense?
So we need to create a job queue too.
Sure.
So it's not
Such a drastic thing to build a linked list of type PCB.
Okay, does job queue need to do anything? Have any methods or anything, or just?
A job queue is just a linked list. It's one of these. Except instead of string in here, it'll say PCB. It'll just like this. There's your job queue. Just rename children to job queue. Fill it with PCBs that you're creating. So as your process scheduler is asked to create a new PCB, he'll create a PCB with the next process ID, fill it up with some random instructions, just put some jibber jabber strings in there. You can just fill it with, instruction 0, instruction 1, instruction 2, instruction 3, and then add it to your job queue.
Where's the job queue located though? Is that in the CPU or?
What's the process scheduler? He keeps track. It's just a list. It's a little piece of paper. Process ID is a job. Process ID 0 is a job. Process ID 1 is a job. Process ID 2 is a job.
So process scheduler is the thing that's actually feeding the CPU.
He's eventually going to feed the CPU.
Okay, so
Right now, all he's going to do is create PCBs and add them to the job queue.
Okay, so
And every PCB needs to have a unique ID. That's it. So I'll give you this code as a starting point. Create a simple process scheduler.
I just don't understand where job queue needs to go. Like, is it a separate class?
No, a job queue is just, it's literally this. Put that at the top of your process scheduler class.
Okay, that makes more
The
sense.
process scheduler maintains a linked list of all the jobs that are on the system. Okay, so somewhere in here, we got to start critically thinking. Once you just start thinking like the operating system's this village, all these things are happening, yada, yada, yada. All right? So, simple version of process scheduler is, what does he need to do initially? Just like the exercise we did today.
Okay.
All right? I will see everybody on Monday.